Okay, so I asked you to read the lecture 6 and lecture 7. Yes, the slides, the videos, lecture 6 and lecture 7. Let's do a recap of lecture 6, and in particular this lecture 6. There are some important concepts which every functional programmer should know. Can somebody tell me what is in lecture 6 and lecture 7, the major ideas? Let's start with lecture 6. The major ideas in lecture 6. Hello.
Hello. So in lecture 6, they start by discussing types for procedures, compound data.
Okay.
Then they talk about how complex patterns can be captured using type-related designs, and then that leads to higher order procedures.
Okay.
In complex patterns, they talk about summation in particular.
Uh-huh.
And for higher order procedures, which is input output both function procedures for procedures, they talk about derivatives, and then they go on talking about higher order procedures for data structures in particular. So they consider
Okay.
list
All right. All
and
right. Okay.
transformation, filtering, mapping
All
related.
right. Very good, Devani. Very good summary there. Okay. So they are talking about, they are motivating the higher order procedures. So, but they don't go deep into higher order procedures. They just define them and they move on. So I think in this class, we can try to delve a little deeper into those higher order procedures. Okay, so let's try to, can you write let's write a function, double, okay, double and a list. So if I say double and a list 1, 2, 3, it should give me the list. It should give me the list 2, 4, 6. All right, let's write such a function. Now, how do I write such a function?
Thamma class.
Pardon? Hello? Hello? Somebody said
Sorry,
not.
sorry, it was mistake.
Okay, yeah. So let's try to write this function. How do we write this function? Can somebody write it and tell me? All right, I think, so how do we write this? We have to define a function, dub, define, let's say dub, let's call it dub or dbl, okay? Double, let's call it dbl. Okay, dbl, and then I have a list. So I'm going to follow the Haskell notation, which is that everything which is variable will be x, y, etc. Everything which is a list will be x's, y's, z's, etc. Okay, so that we have some. It's called Hungarian notation or something. Anybody remembers the name? The Haskell people here? So basically the idea is that by looking at the variable, I would be able to know if it is a single variable or if it is a list. If it is a list, it will always end in S. S stands for sequence. So double x's. So I want to write this function double x's. Now, so now what follows is a case analysis. Yeah. Hello. How do we write this function?
So first we check if access is null.
Okay. All right. So let's
if it
write
is null, then we just need to return nil as the double list.
Okay.
Okay.
Let's write that. If null, then x's, then we will return the empty list. Let's return the empty list, or is it nil or null? I think it is nil now.
Sir, it's nil. Yes.
It's nil. Otherwise, let me write it here.
Otherwise, we can just const the twice of the first element with the rest of the list,
All right.
with this function applied to the rest of the list.
Okay. So first, my function, what does it check first? If it checks if the list is nil, the list is empty. If the list is empty, I'm returning an empty list. Otherwise, I take the first element. What is the first element? The first element is char of xs. Now I need to create a new list which doubles this first element and cons it with the rest of the list. What is the cons of the list? Rest of the list, it should be double of cadre of xs. Yeah, everybody gets this code. Yeah, so let's go through that code once more. So if I check the list is empty, if the list is empty, I return nil. Otherwise, what should I do? I am going to do a case analysis. Yeah, if it is empty, I return the empty list. Otherwise, I take the first element, that is char of xs, and I double it, and I'm going to create a new list. So the first element of the new list is going to be double the first element, and the rest of the list will be calling double on the rest of the list. So double of list 1, 2, 3 will be 2 for 6. Okay, I get this. All right. So now if I want to, let's say, let's imagine I want triple TPL should be 3, 6, 9. If I want to do this, I can copy this code. Yeah. And what should I do?
Replace 2 by 3.
Replace 2 by 3. Okay. That works fine. I have to replace this double by TPL also. Okay. And what I have is TPL 1, 2, 3 will be 369. So, but I have done a grave error, which is that I have copied code. Okay. So ideally, when you're writing a program and you are doing just what I did, that is copying code and replace some of it by another thing, then it already implies that there is something wrong with my code. Okay, it already implies that there is some larger pattern or a more general pattern of which these two are instances. Yeah, that's what it means. Like whenever I'm copying code and changing something, it means that there is an even larger abstraction of which these two are instances of. And then I should try to find the larger pattern and code that and do the particular two instances as special cases. Okay, so let's try to find out what is common about these two things. So what is common about these two functions? What is common about these two functions, these two procedures?
It is applying a particular function to a list of elements.
Yeah, exactly. Thanks, Saina. So both these functions both procedures are of the form apply a function to each element of the list. Okay. So both these procedures, this procedure applies the function multiply by 2 to this one, and this function applies multiply by 3 to this to the list. So therefore, then I should try to write a function. So let's try to write a function, write a procedure which that takes 2 arguments. What are those 2 arguments? A function and a list, and that function and a list. The function is applied to each element of the list. Okay, so that's what. So this function I'm going to call map. Okay, so the general form will be map func list. This will be my function, map func list. So if I have map func list, then what the first case will be an example of map. What will be the first function? Map of, what will be the function? Multiply by 2, or let's call it so let's write that first function later. Okay, so how do I write this function now? Map func list. Can somebody write it? So this will be the way it will be called, map func and list. Can somebody write it? Hello?
Yes, sir. Its structure is quite similar to the code that we've written above, just with a few modifications.
Yeah. So can you try to write it? Can everybody try to write it? This map func list in your Dr. Racket? Hello? Are you trying to write it? Can somebody show me your screen?
Yes, sir.
Yeah. Can you show me your screen? 1 second. Let me. Yeah. So you should be able to share your screen. Yeah. Okay. Okay. Map func list. It will be if null list nil, otherwise cons of func of car of, all right, and map of color of map of you have to there should be func is also should be there. Yeah. No. Before that. Yeah. Yeah. Map of, yes, func of color of list. All right. Yeah. Can you? Okay. So let's define a function double. So just define a function double. Define lambda. Just define it as a lambda, or you can pass it as a lambda. Yeah. Map of then lambda x to 2x. Yeah. Okay. And no. It's not a back quote. It's a front quote. Yeah. Okay. All right. So that's, you have done multiply by 2 to this one. All right. Thank you. Thank you, Devani. All right. So is everybody able to do it? Let's do it once here. So I have to define this function define. and it takes map, and it takes two arguments, a func and a list. Okay, and what does it do? If the list is empty, if null of list, then I have to return a nil list. Otherwise, I apply the function to the char of the list. So I have to cons with func of, apply the first element of apply func to the first element, char of list, and I apply map to the rest of the list, func of cadre of the list. Okay, and that's it. Now if I apply map of lambda x2 times x3 to list 1, 2, 3, get 369. I guess everybody is all right with this, the map function. Shall I proceed?
Yes, sir.
Okay, so that is a map function. All right, so the three functions which we are going to learn now, map, then filter and fold, are generally called the functional programming toolbox. Okay, because they are so useful. And if you have heard of Google's MapReduce, Google uses a big software called MapReduce. These functions exist in Python also. In Python, they are called map, filter, and reduce. Python. And map, filter, and fold is the same terminology which is used in Lisp and Lisp, Haskell, etc. Okay. And in Python, they are called map, filter, and reduce. Almost the same syntax. Okay. But in Python, you don't have arbitrary lambdas. Your lambdas are restricted to just expressions. So because in Python, you have state. Yeah. So almost you can look it up. What is the syntax of map and filter and reduce in Python? Almost the same syntax. Yeah. So the Google has a software called MapReduce, which is what their map software, this Google Earth and all this Google Maps, etc. is based on this MapReduce, and it's just a application of these three functions to the map, in the sense that to the geo location. So that's why it's called MapReduce, and it's one of their big successes, this MapReduce software. Yeah. All right. So yeah. So map is this function, which is a higher order function. So let's also try to write the type of map. Type of map will be, I'm going to write it in Haskell syntax. Okay. So type of map will be, if my function has type A arrow B. Okay. If A could be some integer or Boolean or something like that. Okay. And A arrow B means that I have a function. Map takes two arguments. One is a function, the other is a list. Okay. List, I write it as a box. And so it takes these two arguments and gives me back a list of type B. Yeah. So in other words, let's write it this way. Function has type A arrow B, sum A to B, and list is of type, let's say list is of type A, and map is of type A arrow B, takes two arguments and list type, and then gives me back a list of type B. Okay. In Haskell syntax, you would often write this as this one, because Haskell is curried. can look it up. What does that mean? But Lisp is not curried. Curried means that all functions take exactly one argument. Okay, so map takes a function A or B and a list of type A, and then gives you back a list of type B. For instance, in this case, A and B are both integers. So it takes a function of type integer to integer and a list of integers and gives me back another list of integers. Okay. Now let's do the function filter. So what is filter? Filter function do? Filter takes a predicate. What is a predicate? It returns all the values. Satisfying the predicate. So for instance, if I say filter, and what is a predicate? Somebody tell me what is a predicate?
So that's a condition.
Yeah, but more precisely? More precisely, what is a predicate? In programming languages, when do we say a function is a predicate?
So if it returns a value true or false.
Yes, if I have a function which returns me a true or false value, that's what I call a predicate. Because predicate in general is a qualification. Okay, so for instance, is blue is a predicate. Yeah, because you can say X is blue has either value true or false. So things like that are called predicates. Okay, so yeah, so to repeat, a predicate is a function which has a true or false value. Okay, so if I have filter, and let's write a true of a function like x greater than x3, x is greater than 3, then if I have a function 1 1 2 3 4 5, what should be the answer to that? So if I have a filter which takes a function and a list and returns me all the elements in the list which satisfies that predicate. So 1 does not satisfy, 1 is not greater than 3, 2 is not greater than 3, 3 is not greater than 3. So this list will return, this function will return 4 and 5. Okay. All right. Hello.
Yes, sir.
Okay. So let's try to write this function filter. Can you try to write this function filter, everybody? And I will ask somebody specifically this time. What is it? Who is going to do it? Who can do it? Anybody? Hello? Bhavana? Bhavana? She's mute.
Yes, sir.
Can you show me your screen? Can you try to do it?
Yes, sir. I'm not having daughter racket in my laptop actually. I can tell you what I've written.
Okay, tell me.
Like what I've written.
Yeah.
So, sir, filter will be having two arguments,
Okay, define filter. Let's call
pred
it.
and at list.
Let's call it pred and list.
List. Yes, sir.
Okay. Okay.
Then we have cont,
We have a cont. Okay.
and in that first is if it is null question mark list.
A list. Okay.
then answer will be nil.
Answer will be nil.
And second thing is pred,
If it is spread,
first of list.
okay, first of
Then
list,
first of list.
which is care of list.
Yes, sir.
Okay, pred care of list. And
Then adjoin of
let's okay, adjoin of, which is cons now.
yes, sir. First of list, matlab care of list. Care of list, then filter. Filter with argument pred and cadre of list.
Okay.
Then else filter
1 second.
with two arguments. Yes, sir.
Else.
Then filter with two arguments pred and cadre of list.
Filter with pred and
cadre of list. Yes, sir.
okay. So let's try to check this function. I have filter pred of list will be, I'm going to do a conditional case analysis on that condition. If it is null, if the list is null, I'm returning the empty list. Otherwise, I check if the first element of the list satisfies the predicate. If the first element of the list, care of list, satisfies the predicate, then I'm consing the first element of the list and a filter applied to the rest of the list. Filter pred of cadre of list. And if that is not the case, if the first does not satisfy the list, then else I just apply filter to the rest of the list. Yeah, that's my function. So let's try filter of lambda x greater than x3, and let's say 1, 2, 3. Expected number of arguments do not match.
So the lambda, you didn't close the bracket.
Okay. Filter lambda x greater than x3, 2, 3, 4, 5. Will be 4, 5. All right, very good. So we got it down. That is a filter. All right. Now, so all right, I think filter is not very difficult. It's just like map, except that we decide to append to the list only if it is returning true. Yeah. So filter is kind of a map, but yeah. Both these functions are in general called transductions because they are transducing. Yeah, we have a list, and it's like a little machine which goes to each element and then decides what is output, and then does that. 1 second. 1 second. Where is it? Okay, so now let's do the last one, which is fold. No, sorry. Let's do the last one, which is fold. Can somebody tell me what is fold? Anybody remembers what is fold?
Fold takes a list of elements and it will fold all those elements based on an operations, like maybe adding all the elements of the list or multiplying all the elements of the list.
Yeah.
And
Let's start with that. Yeah, let's start with that. Adding all the elements of the list. Adding all the elements of the list. Of the list. Let's try to write this function. Okay. Adding all the elements of the list. Let's quickly do this one. Define some list, sum L, and it takes a list access. And what should be this sum L? It should be, can be an if null access. If it is if the list is empty, I return 0. Okay. Otherwise, I should otherwise I am summing, I'm adding char of I am adding char of the list and the sum of the cadre of the list. Yeah, should be sum L. This is what is, so I have if the list is empty, I'm returning 0. Otherwise, I am adding the first element and the sum of the rest of the list. So if I do sum L of 1, 2, 3, 4, it will give me for its definition. Yeah, it gives me 50. Let's do multiplication of the list. Multiplying all the elements of the list. In which case it will be define mul L access will be again the same pattern. If null of access, then I am returning empty list should give me back what? Somebody tell me.
Sir, 1.
Empty list should return me back 1. Otherwise, I will multiply the first of the list and the mul L of cadre of the list. Little different. That's for factorial. So already we see that there is something going on, some common programming pattern. This kind of things are called programming idioms, by the way. Idioms, okay. Just like in English language, you have idioms. Yeah, idioms means so the idea is that it's a similar pattern which is going on. So what is this pattern? Let's try to understand this pattern. What is the pattern about? Let's try to understand this pattern. Okay, so this pattern is like this. If I have a list, let's imagine if I have a list x1, x2 up to xk. Okay, that's my list. This is my list. Okay. And so what are the elements? I have a list, and I have three things involved in this computation. One is a function, and the other is a value, and a list. Okay, three things involved in the computation. Now, how is this computed? So initially, it is computed like this. First step will be you take f of xk and value. So empty list corresponds to value. Okay, that's what our first one means, because here empty list corresponds to the value 0. Here empty list corresponds to the value 1. So that is what this value is. Okay, everybody is clear? Yeah. So the pattern, I'm describing the pattern of these two computations. So I have a value which is a 0 here, which is 1 here, which is based on when the list is empty, what is the value to be returned by the list, returned by the function. So if the empty list is given, then this value should be returned. And if the list is just one element, let's imagine the list is just one element, x1, in which case what will be the return value? If the list is just one element, let's get rid of this. If the list is just x1, what will be returned? It will be some function func applied to x1 and value. That will be returned, because recursively, when you dig deeper into this x1, what will happen is that it will first apply a function which is this plus here, which is multiplication here, which will apply to the first element of the list, which is x1, and the rest of the list, function applied to the rest of the list, that will be value. Yeah, clear? Any doubt? If you have any doubt, ask me. And if it is two elements, let's imagine the list is two elements, x1, x2. Can you tell me what will be returned by the function? Let's call this f. Okay, let's call this f, and let's call this v. So if it is two elements, f1, x1 and x2, can you tell me what will be returned by the function?
f of x2 comma f of x1 comma v.
F of x2 comma f of
x1
x1 comma v. That will be returned. Is it clear? Because let's try to understand what will be the computation. How will the computation look like? So computation will come and it will do a case analysis on this list, and this list is not empty, so it will take the first element x1 and apply the function f to the first element x1. So it will be x1, sorry, it will first apply the first element f of x1, and recursively it will call f of x2 and v. Okay, and if it is three elements, if the list is three elements, x1, x2, x3, it will be f of x1 comma f of x2 comma f of x3 comma v. It will be like this. Okay, all right. So this function, you can in one sense you can see it like this. I have this big list spread out in front of me. Okay, and I'm going to fold it. Okay, what does folding means? Like imagine you have your list spread out like a carpet. Okay, on the left end you have x1, on the right end you have xk. Okay, the list is spread out like a carpet. Now what I'm going to do, I'm going to take a value v and spread it all at the end of that carpet, which is our list, at the right end of our carpet. Okay, and now what I'm going to do, I'm going to fold it. I'm going to take that value v and the last element of the list, I'm going to fold it once, applying f. Okay, now that becomes one value. That I'm going to take that value and I'm going to take the second last element xk minus 1, and I'm going to fold it once more, applying f. Okay, so it's like a carpet, folding a carpet like this. Can you see the analogy? Do you get what I'm saying? It's like a folding a carpet. Yeah, rolling it inside and inside and inside. Okay. So yeah, so if I have k elements, I take the last element, put it at the end of the list. I fold it once, and then by applying f, and then I fold it. That becomes a value. I take the second last element, I apply that value and the previously gotten value, apply it to f, and so on and so on. Yeah. Is it clear? So what will be, so for the sum, L, for summing a list, what will be V? V will be 0. What will be F? What will be the function F? What will be the function F?
Plus operator.
Plus operator. For multiplying a list, V will be 1, F will be multiplication.
It's 11 o'clock.
Okay. Actually, you can go even further. Okay, because for creating a list is also a similar operation. If you think about it, V is actually nil and F is const. Okay. So the way we create a list is applying, you can think of creating a list is also, you can think of it as applying a fold right operation. Okay, where the last element of the list will be nil and F will be nothing but const. Yeah, you can append the empty list at the end and apply const operation to the last element and this one. Get it? Is that clear what I just said?
Sir.
Yeah.
Sir, but in this case, I don't see how we are folding it. Like in that case, we were accumulating something like
Yeah, I get your question. So you are saying that in this case, we are not reducing the value to a single value. That is
yes, sir.
That is not necessary. Yeah. So you are thinking that whenever we are applying a function, the output value has to be something simpler than the original value. It need not be, because in computation, we never told that whatever applying a function has to result in a simpler value. Need not be the case. Okay. For instance, when we are creating a list, that function of creating a list does not create a simpler object. It takes simpler objects and creates a complex object. Yeah. Creating a data structure, creating a constructor function always gives you something more complicated than its input constituents. Okay. So yeah, so computation need not always involve synthesis. I mean, what is it? Reducing things. It always also includes synthesizing new elements from simpler elements. Okay, so this kind of rewriting is called free rewriting, in the sense that you are not applying anything. It's just it's a bit complicated to explain. I mean, basically what you're saying is that when you apply the operation, you are the resulting value is nothing but the operation itself. Yeah, I mean, yeah, let's not go deeper. For the moment, this is enough. Okay. So this is what is fold operation, fold right. All right, exercise. Create I will put the exercises in a separate function in WhatsApp group. Okay, so can we write this fold right function in Lisp? How do we write the fold right? So fold R, it's called fold R in Haskell. Fold R will take a function f and a value v and a list access. This is what it will take. Yeah. So can somebody tell me how the function, let's write it together. So define fold R f v access will be Can you help me? If null of xs, then
Value v.
then I get v. Otherwise,
We do f of
f of char of
care
xs
of xs and
and
and the fold r of f of v of color of xs.
f of v of fv color of xs. Okay.
In the entire f of that.
Pardon me.
Nothing. It's right, sir. It's right. Nothing, sir.
Okay. So you see that it's almost the same pattern. If null of x's, then I have a v. Otherwise, I apply the function f to char of x's and fold r of f of v of order of x's. So we have generalized this this pattern. Yeah. Char the fold r function.
So we are missing a bracket, sir.
Where am I? One second.
So because it is f of char of xs and the remaining part.
F of char of x's and
so like it's f of char of xs comma folder fv color of xs. So I think we are missing a bracket.
one second.
To encapsulate both the terms.
Okay, so this is right.
Yes, sir.
Now this is right. This is right now. F of.
Okay, sir. Okay, sir. Yeah. Fine. Yes, sir.
All right. Let's try to do this. Fold R of. What is a function? F is a function. So a function I should write it as lambda xy. The addition function plus of x comma y. It takes two arguments and returns a sum. And value v should be 0 and okay, I have to run it. Fold R of lambda xy forgot to take then the value. Okay, so that's right. Okay, so that is what is fold R. Let me tell you, similar to fold R, there is also fold L function, the left fold, and then there is the right fold. So in the left fold, what happens is that instead of writing it on the putting it on the right, the value on the right, and folding it this way, folding it counterclockwise, you put the value on the beginning of the list and fold it clockwise. Fold the carpet on the clockwise direction. Okay, so that's two ways of folding a list: either fold from right or fold from left. Now these two folds have implications in the runtime evaluations, and you can also express if you have only folder, you can also express folder in terms of folder and so on. So there is a whole theory of these three operations. It's called it's an algebra, in the sense that, you know, just like you have addition, multiplication, you can develop a theory of list operations based on fold and fold operations and map and reduce and so on. Anyway, so this is what these three operations are. Now we have only 5 more minutes. Let's try to write a simple sorting function based on for these three operations: filter, map, and map, filter, and fold. You don't need. Okay. So imagine I want to write quicksort. Generally, the quicksort function takes a list, and what does it do? You can actually define this quicksort function like this. It actually list I'm going to put okay. So one way to sort a list is like this. I take the first element of the list, which is char of list, and I create a list which contains all elements less than this char of list. And I create a list which contains all elements greater than this the char of the list. Okay. So I get this two list. So, and then what I do, I take this list, append char of the list to the right of the first list, and then I append all the elements which are greater than the char of the list to at the end. Yeah. So if I want to sort a list, this is my strategy. I take the first element, then I find all the elements of the remaining list which are smaller than the first element. Let me call it L1, and let me call L2 all the elements of the list which are greater than the first element of the list. That's L2, and my sorted list will be L1. After L1, I append the first element of the list, and then after that, I append all the remaining the list L2. This is my strategy. Now, can you write list code so that you apply this one? So one thing is that you can use filter function here. For what? Can you apply? You can apply filter for what here?
Sir, for L1 and L2.
Yeah, for L1 and L2, you can apply filter. And so here you will need to write another function which will append an element and or a list to a list. This plus plus operator. Yeah, in Haskell it is called plus plus. I'll say append. Okay. Okay, so this is what you have to write. All right, so you write that and post it in Piazza. Okay, so that is one. So let me write exercises. One. Write quicksort using filter. 2. Find examples, other examples of map, filter, and fold. Okay. So in the sense that think about especially let's say other examples of fold. Okay, and find other examples of fold, and I'll post some more examples, some more exercises for map and filter. This one. Yeah, and for Wednesdays, so we only got time to look at those three functions. But I think that is the larger message of this chapter, these higher order functions. Okay, now they give you derivatives and integrals. It's slightly more complicated, but yeah, but it's okay. I mean, even if it's a very mathematical kind of example. Yeah, would like to. Okay, and the next good programming practices, I think we don't need much. I mean, you understand what it means. So we need not take it up in the class. But anyway, let's try to discuss that in the next class.
There's definition of tree at the last of the lecture.
Okay, so let's do that, because anyway trees are going to be an important this one. Okay, so and yeah, for the next class, can you try reading L7 and L8 also once more? L8 also using higher order procedures. If it is not too difficult, L8 will be useful. It will be fun because in Dr. Racket you will be able to draw these pictures. Yeah, you will be able to draw these pictures in Dr. Racket. How are you enjoying this one? Are you able to? Is it too boring? Hello. All right, I take it as a yes. Yeah, but yeah, just hang in there. You will get I guess it will be better. Yeah, going forward, because now you are learning the language also a bit, and yeah. So, but take care of if you don't understand whatever I did today, this map, filter, and reduce, it's very important. Because in Lisp you will be using map and filter and reduce all the time. Yeah. All right. So then I will take leave. See you on Wednesday. Any questions?
I have one difficulty in this filter function. Can I share my screen?
Yeah, please. 1 second. Let me close my screen. Stop my share. Yeah. Go, Jarrett.
So I had written something like this.
Yeah.
But it is not.
Define filter lambda pred list. If null list, nil. If pred char list, cons of char of list and filter of pred of cadre of list. Otherwise, filter of pred of cadre of list. That is correct. Okay. Now what happened?
But in the when I run this here, it is showing. I mean, it is only.
Yeah, that is correct. If you say filter of even, that will give you only 2.
Let me. So, but this, if I don't, so this way also is okay, no, sir, without condition.
What is without condition?
In your code, you had written condition.
Yeah. This is also fine. Condition is just a switch statement in like in C. Just a switch statement.
Oh, okay.
All right. Okay. The cond is just a switch statement.
Okay.
Okay, then. Thank you, everybody. Thank you, everybody. Bye.